All right, good morning, folks. Week 2 of remote learning. I am going to cover at least one more section or at least one more topic today. I might need to readjust a little bit pacing for the week, but we still have our first quiz coming up, and I'll put some information about that on the course page for you. Hopefully after you watch this video, you can check up on that. So the exit ticket from Friday's Google form had this information given to us, and we wanted to find sine of 2 theta. So using the triangle here that we constructed from the tangent ratio given to us, and the restrictions on theta kind of narrowed it down to third quadrant, we can find whatever ratio for theta we want, specifically sine theta, cosine theta, because that's part of our double angle formula for sine. So simply plugging those all in, we get positive 8 over 17. Now, the second part was also asking what quadrant could 2 theta fall in? Well, we were given that theta was kind of bounded between pi and 3 pi over 2, which then if I double everything to get 2 theta, now we have this angle 2 theta is bounded between 2 pi and 3 pi. So that can narrow it down to quadrants 1 or quadrant 2, which makes sense because, of course, we had sine of that angle as positive, and that's also quadrants 1 and 2. But we can actually go a little bit further. And some of you got this, some of you didn't think to go a little bit further down. If we take into account the value of cosine of 2 theta, whether that's positive or negative is going to allow us to further narrow it. So again, I just used cosine squared minus sine squared formula. You're going to get a positive value of 15 over 17. Well, if cosine of an angle is positive and sine of the angle is positive, then it has to be quadrant 1. So we can narrow it down as much as possible. You should narrow it down as much as possible. So I am moving on in our chapter, and this is actually the only example I'm going to give you today. Half angle formulas, and you can breathe a sigh of relief. These are the last formulas from the chapter. In fact, these are probably going to be the last formulas for a bit, because chapter 10 kind of inundates you with a lot of angle formulas. Keep in mind, you're going to be allowed them as a reference material for any assessment coming up. So take a moment and get these all down. You'll notice, obviously, sine of half of alpha. We have this little plus minus symbol, and I'll talk about that when we actually get to this example down here, because it's also pops up in cosine as well, and tangent. And that kind of is dependent on the angle. And I'll reference that in a second. Tangent has not one, but 2, 3 formulas. They're all equivalent. It's kind of like the cosine double angle formula. You can use any one of these you want, and they'll all be equivalent. Most students will choose one of these just to avoid the massive square root and the plus minus, but all 3 of these are equivalent. Okay, so let's kind of tackle this. I want to find the exact value of cosine of 5 pi over 8. So 5 pi over 8 is, the first thing you want to recognize is 5 pi over 8 is in quadrant 2. And the reason we want to consider that is I know cosine in quadrant 2 is negative. So that's going to tell me this whole plus minus in front of it. I'm going to choose the negative root of my formula, not the positive root, and that depends on what quadrant the original angle we're evaluating lies in. Excuse me. Now, further, going back to the formula, this 5 pi over 8 represents half of what the alpha is, and the alpha is the angle we're actually using in my formula. So if alpha over 2 equals 5 pi over 8, hopefully you recognize alpha is 5 pi over 4. All right, so that's the one we're going to use for all of our, well, our only trig function here. So finally, we know, again, it's negative because of the quadrant 2 of the original angle, and we're going to use 1 plus cosine 5 pi over 4 all over 2. Now that 2 is still inside the square root. From here, it's a matter of evaluating and simplifying. So we have a 1 cosine 5 pi over 4 is a negative rad 2 over 2 all over 2, which I can then kind of do that keep change flip. If I'm dividing by 2, you multiply by the reciprocal 1/2, and I'm going to do that to the numerator. I just realized I forgot my negative there. And then we get a negative 2 minus rad 2 all over 4. I just kept it as one term. Again, you could also just say, well, I'm going to multiply by 2 over 2 to get that. This doesn't simplify a whole lot, but the only thing I can do is this square root applies to both the numerator and denominator. So the square root of 4 is obviously 2, and then we still have this negative square root in the numerator. It's going to look awkward, but it's totally acceptable leaving a square root inside of another square root. And this value is your final answer. So that is the cosine of 5 pi over 8. Notice a couple things we have to really be careful about. First is determining what quadrant the original angle is in, all right? Excuse me. Because that's going to determine whether I want the plus or the minus of those roots in front of our formulas. Secondly, you have to actually figure out the alpha you're using in your formula. Keep in mind, the original angle is not alpha. This is alpha over 2. So again, you double the whatever the angle is to figure out what piece of information am I actually computing in the formula. And then from there, it's a matter of very carefully simplifying. I'm going to leave it there because I think this is a topic that just demands a lot of practice. So I'm going to give you that opportunity to work on that today. All right, good luck.